Yes, so in the last class, we had completed with motional EMF, right? Now, methods to produce EMF also we had seen, magnetic field, area, these three things I have told you, that relative orientation. One more thing, that this is not just for your JEE part, magnetic field, area, relative orientation. This is for your CBSE also. This question separately can be asked to you. Fine. Now, one more thing, formula of power, formula of force also we have seen. How forces are present and are changing. From this, we didn't practice any question, no? One question I want you to practice. Then some portions are only left from this lesson. Let us complete it quickly and we'll start with alternating current then. One question from this. See, let me draw the figure, then try. Answer is very easy. This should take just 30 seconds to all of you. Let me draw the figure first, then it will give you an idea. Then draw it. Yes, class. This is the figure. Now try. Okay, Fadil, I'm just waiting for your answer. Shahid has already answered 2 minutes ago. T class, the answer to this question. No, see, Shahid, the formula you are using is correct, but that is not the exact formula. Formula is E L B cross V. So if V and B both are parallel, then EMF will be 0. Here, when you open this is sine 0 degree. Okay, this is the answer. So that's why this shouldn't take, whenever, as soon as you see the figure, V and B are parallel straight away. In your options, this will also be, one option will be saying BLV, one option will be saying 0. So BLV would sound more appropriate over here. But the actual answer is 0 because both of them are parallel to each other. Sine 0 becomes here. Fine. This is the question which I wanted to discuss. Rest of the questions are formula based. You people will be able to do. Write it down. Yes, yes, Fadil, directions will be given in the form of figure, in the form of question, written text, it will be mentioned. If it's not mentioned, then the answer would be option A, that is BLV. That's why I'm saying this is a tricky question. It's very easy. Otherwise, your answer is simply BLV. But since it is mentioned specifically through the figure, see, nothing was given, nothing was written until you see the figure. And also in the figure, so slightly it is mentioned. This you have to observe that V and V are parallel. The figure I have made, this won't be given to you in the question. This I have made so that at least you people will have an idea while writing. C class. This says any answers till now? Because here you will get a direct value. Okay, let me discuss. See, why did I draw this figure? Because you have to consider a very small section which you will be expanding to calculate the EMF. Fine. Basically, 95 into 10 to the power minus 5. No. 9. This isn't the answer. See, DE is equal to basically BVLV, right? BLV. So instead of L, I'll be writing DX because I have to take a very small length. Just a second, class. So DE is equal to BV dx. Now, when we integrate this, this will give you EMF. Now, whenever we are talking about B, magnetic field, you have to substitute in the value mu naught I by 2 pi x, because this is not given to you in the question, right? Velocity is mentioned, magnetic field is not mentioned, straight wire is given. So you have to draw it in that manner. Fine. Then you can write V dx and integrate it. Now see, rest of the things are constant. Whenever you are integrating it, differentiating it, you can write E C mu naught I V 2 pi integral of dx over x. Fine. Now, yes, what are the limits that you will be setting? What are the limits that you will be putting? So see, you have to take a certain separation. Suppose, let's write it in terms of radius. Let's say this x, the separation till P. This separation till P, this is R. Fine. And the separation till then, see, length of the rod is L. So entire separation will become R plus L. So from where do we have to integrate? From P to Q. So you will be taking from R to R plus L. This is the, now this integration is not difficult for you people. This integration you already know. Mu naught IV by 2 pi. Now, when you are integrating, this will give you log x, log EX, R2, R plus L. Fine, R2, R plus L. Now, again, upper limit, we'll put the upper limit first. So that becomes log R plus L minus log R. Okay, log A minus B rule, do you all know? What is log A minus B? Anyone? Log
Log A by B, ma'am.
Log A by B, very good. So this will be R plus L divided by R, right? R plus L divided by R. Now C class, you all have to substitute in the values. EMF values you have to put in. You know R, you know L, velocity, current, pi, mu naught by 2 pi is already there. 10 to the power minus 7. 2 into 10 to the power minus 7. See, mu naught by 2 pi is 2 into 10 to the power minus 7. Current was also given 5 amperes. No? And velocity 10 meter per second. 5 meter per second. Okay, current is 100. So current is 100 amperes. Velocity is 5 meter per second. Okay, 2 pi already I have cancelled. Then log. One was radius was 1.0, and other one was 19 divided by 1. That is log 20. So this is 10, this 1000, 3, 10 to the power minus 4, log 20, because this is just 1, right? Log 20. So this is log 20 is 3, around 3. So 3 into 10 to the power minus 4 volt. This is the answer. This is the final answer. Around this should be your answer, Fadil and Shahid. Please write it down. Anywhere you people are having doubt, let me know. Now is this clear? Yes or no?
Yes, ma'am.
Shahid, did you understand why it's not 95? Okay.
Yes.
Okay, one thing, class, that I wanted to discuss was from, see, rest of these portions, these are over. From inductance, self-inductance, mutual inductance, rest of the formula we have already done in the class. Derivation and how do we write it, that's already been discussed. But it's just that one thing that I wanted to discuss was, if you're getting a concentric figure, like this is the case of a concentric circle, right? So two radii will be present. This one, right? This is R1, this is R2, right? So remember, mutual inductance is directly proportional to R2 square by R1, where this is a condition that R1 has to be greater than R2. Fine, R1 has to be greater than R2. Or one more thing, just make it as a see. Suppose this is A, this inner one is B. So mutual inductance is directly proportional to B square by. Again, this B is, I have drawn it huge, but this is actually tiny. This is not huge. So this you should remember just in case. Both the combinations are given to you. See, you are given a square also. And a circle also. This is radius R and this separation is A. So mutual inductance will be directly proportional to R square by A. Again, the circle which is present inside is tiny. So three combinations you have to remember. One is square plus circle. Second is two concentric squares and two concentric circles. Write this down as a note point, please. See, this question says that a solenoid has 2000 turns wound over a length of 0.3 meters. Area of cross section is 1.2 into 10 to the power minus 3 meters square. Around its central section, a coil of 300 turns is closely wound. If an initial current of 2 amperes is reversed in 0.25 seconds, find the EMF induced in the coil. So this has not mentioned you which induction you have to use, which value you have to use. But see, if it is saying two coils, one is present in the center of other, it means mutual induction you will use. Mu naught N1, N2 area over length. This formula is sufficient. And once you have mutual induction, you can use it to calculate EMF. Value formula of EMF, I hope you remember, E is equal to minus M DI over dt. You will use the same. See, this is 4 pi into 10 to the power minus 7. 2000 turns, no? That was 2000 turns. Inner one was 300. Area of the cross section was 1.2 into something 10 to the power something was given. 10 to the power minus 3 into 10 to the power minus 3 divided by 0.3. See, this will become 0. This is 1000. 4. So minus 3 plus 3. This will go off 2, 4, 3 point something. Let's take it as 3 into 10 to the power minus 3 Henry. Around this much it should come. Please check the precise value later. This is just orally I've done it. Minus dm di over dt is the formula. This is minus 3 into 10 to the power minus 3. Now what about the current? Current was 2 amperes, right? It was coming 2 amperes. Now this was reversed in 0.25 seconds. So 1 you have to take it as minus 2 if you are taking 1 as plus 2. If you're taking this as plus 2. So this becomes minus 2 divided by 0.25. So 4, 1 over 4. So this will become 48 into 10 to the power minus 3, or it will be 48 millivolt. This is the answer. Just main thing, rest of the calculations you'll be able to do. The thing is that you have to relate that here. Firstly, mutual induction will be used. The first point is. Second, you can use this mutual induction to get the value of EMF using the concept of this formula. Write it down. First the question.